Welcome to the lecture series of digital electronics. Today we will discuss the subtractors, a combinational circuit design. The subtraction of two number may be accomplished by taking the complement of the subtrahend and adding to the magnitude. But by this method, the subtraction operation become an addition operation require full adder machine design. But it is also possible to implement the subtraction with logical circuit directly, like as an adder. And it can be designed with the help of pen and paper. By this method, each subtrahend bit, the number is subtrahend from its corresponding significant minute bit to from a difference bit. If the minute bit is smaller, then the subtrahend bit is a 1 borrow from the next significant position. Okay, so like as an adder, the again here there is a three parameters are there. If we consider only minute and subtrahend, so at that time it is known as a half subtractor. And if we are considering the borrows from the higher stage, a binary signal coming out of a stage and going into the next higher stage, it is just as a full subtractor. So there is the two type, half subtractor and full subtractor circuit. So let us start with the how we can design this combinational circuit. In if I want to perform the x minus y, so if x is greater than and equal to y, remember that thing both are a single bit, x and y. So only two values are possible. X may be 0 or maybe 1. But if x is greater than or equal to y, then there is a three positive. One is the 0 minus 0, means x is 0, y is 0. Result is difference is 0. 1 minus 0, 1. And 1 minus 1, 0. But one condition is remaining, and which is x is less than y. At that time, the x is 0 and y is 1. So the difference between these two number is 1, but there is require one borrow from the next higher stage, next stage or towards the MSB side. So this is the truth table of that things. 0 minus 0, the difference is 0. 0 minus 1, difference is 1. 1 minus 0, a difference is 1. And 1 minus 1, 0, difference is 0. The only thing is that if x is 0 and y is 1, at that time one borrow is required. In for half adder, the carry is assigned here. There is a b borrow sign is that. Okay, while the difference output is similar like as a half adder, some output, and the carry output we obtain when x and y both are 1, while here borrow obtain when the x is 0, y is 1. So the in form of expression, the difference is equal to x dash y plus x y dash, or we can say that it is an equivalence gate, or we can say that it's a XOR gate. While borrow is the x dash y. So the Boolean function of these two output half subtractor are directly from the truth table. D is equal to x dash y plus x y dash, while borrow is equal to x dash y. Right. Now next we take the full subtractor circuit. So full subtractor circuit, again three inputs are there, x, y and z. So first consider all three are 0, x 0, y 0 and z 0. So 0 minus 0, 0, and again the result minus from 0, so it result is also 0. So difference is 0 and there is no required borrow. 0 minus 0, 0, again 0 minus 1, whatever the result, 0 minus 1, again here see 0 minus 1, the difference is 1, and there is also require borrow because larger number is subtract from the smaller number. The 1 is subtract from 0. So borrow is require 1 in this condition. Third, 0, 1, 1. 0 minus 1, again 0 minus 1 in the first stage borrow is required. and difference is 1. Whatever this difference 1, take here, and the third bit is 0. So 1 minus 0, 1. Finally, we can say that the difference is 1. Subtraction of 1, 2 and 3 bit. इन तीनों में से आप देखो पहले कि 0 में से 1 माइनस हुआ तो 1 डिफरेंस है, एंड 0 में से 1 माइनस होने की वजह से बोरो भी चाहिए हमें. नाउ द वैल्यू ऑफ द थर्ड इनपुट इज 0. सो इसका जो डिफरेंस पहले स्टेज का जो डिफरेंस निकला वो डिफरेंस में से थर्ड बिट माइनस किया तो डिफरेंस इज अगेन 1. अभी द इनपुट कंडीशन x is 0, y is 1 and z is equal to 1. 0 1 1. 0 minus 1, the difference is 1, बोरो is 1. यहाँ डिफरेंस 1 आया, वही 1 डिफरेंस में 1 फिर से 1 माइनस करूंगा तो डिफरेंस विल बिकम रिड्यूस टू 0 एंड फाइनल रिजल्ट इज 0 डिफरेंस और 1 बोरो. अभी नेक्स्ट है x 1, y 0 and z equal to 0. 1 minus 0 1, no बोरो. अगेन द ये जो डिफरेंस है 1 में से उसमें से मैं 0 फिर से माइनस करूंगा तो 0 इक्वल टू 1. सो डिफरेंस इज 1, देयर इज नो बोरो. अगेन 1 minus 0 1, no difference. Whatever the result of 1, z minus from this difference 1 minus 1 0. So difference is 0, boरो is also 0. 1 minus 1 0, boरो is 0, and 0 minus 0 0. So total difference is 0 and there is no boरो. 1 minus 1 0, boरो is 0. Now the result of this 0 sub minus z. So 0 minus 1, the difference is 1 and boरो is 1. So we put this all the condition into table like as each and every stage. Here 0 0 0, difference is 0, boरो is 0. 0 0 1, 0 0 and 1. Yes, this one. So the result difference is 1, boरो is 1. 0 1 0, the difference final difference is 1 and boरो is also required. 0 1 1, जब भी पहले 0 आएगा उसके बाद अगर 1 आया तो बोरो मस्ट बी रिक्वायर. जहां जहां भी आप देखोगे कि पहले 0 में से 1 माइनस होता है वहीं बोरो तो कंपलसरी आ जाता है. ओके, एंड नीचे बिलो 4 में क्या है, ये 3 केस में 1 और 0 है. सो इन दिस 3 केस द डिफरेंस इज 1 हियर 1 0 0, while 1 minus 1 difference is 0, 1 minus 1 difference is 0, 0 minus 0 difference is 0, and again boरो not required in these 3 conditions. While in last condition 1 minus 1 0, this one 1 minus 1 0, no boरो. But again whatever the 0 result, 0 minus this one third one bit, the difference is 1 and बोरो is. इसको हम कार्नो पे डालेंगे तो the equation is look like as the difference is equal to x dash y dash z plus x dash y z dash plus x y dash z dash plus x y z, यानी कि exclusive or of x y and z, while the बोरो है वे x dash y plus x dash z plus y z. और उसको अगर हम डिजिटल सर्किट कंपोनेंट में रखेंगे तो ये 2 हाफ सबट्रैक्टर है. द हाफ एडर और हाफ सबट्रैक्टर बोथ आर लुक लाइक सिमिलर. ये याद रखिए कि हाफ एडर और हाफ सबट्रैक्टर में ये जो एक्सक्लूसिव और गेट ही रहता है दोनों में, आउटपुट में सम और डिफरेंस में. और यहाँ जो एंड गेट है वो कि हाफ एडर के अंदर ये एंड गेट रहेगा लेकिन ये इन्वर्टर नहीं आएगा. ओनली द इन्वर्टर इज डिफरेंट. जो फर्स्ट इनपुट होता है x, उसमें इन्वर्टर लगा के एंडिंग होता है फॉर सबट्रैक्टर सर्किट. सो ओनली वन डिफरेंस इज बिटवीन द हाफ एडर एंड हाफ सबट्रैक्टर इज दैट one inverter x dash input is in बोरो while carry x in x y direct connected to here. So this is the first half subtractor. Again this is the second half subtractor and the boro is ORing of first half subtractor and second half subtractor gives the final boro of full subtractor. So this is the diagram is known as a how to design a full subtractor circuit with the help of two half subtractor and OR gate. I hope everything is making sense. In very simple word, we understood that how the full subtractor circuit work. Have a good day.